Have you ever considered how a sudden burst of energy from the sun could affect our daily lives here on Earth? The sun, our life-giving star, is more than just a glowing orb in the sky. It's an active, dynamic powerhouse constantly generating and expelling energy. This energy, released as light and heat, is what drives life on our planet. But the sun has a more volatile side that often goes unnoticed. Imagine the sun as a gigantic nuclear fusion reactor where hydrogen atoms collide and fuse together to form helium. This process releases an immense amount of energy, some of which is expelled from the sun's surface in the form of solar flares. These flares are essentially massive explosions on the sun's surface, releasing energy equivalent to millions of atomic bombs in just a matter of minutes. Solar flares are not uniform. They vary significantly in size and intensity. Some are as small as a fraction of the sun's surface. These are called nanoflares. Though they may seem insignificant, even these tiny flares can pack a punch, releasing energy equivalent to 100,000 nuclear explosions. On the other end of the spectrum, we have superflares, which are thousands of times more powerful than the largest flares our sun typically produces. These flares don't just stay confined to the sun. They can eject a stream of high-energy particles known as a coronal mass ejection or CME into space. When these particles reach Earth, they can interfere with our planet's magnetic field and atmosphere, leading to a host of effects, some of which we'll explore in the next scenes. So, now that we understand what a solar flare is, let's delve into the events leading up to a massive solar flare. The birth of a solar flare is a spectacular event that starts deep within the sun. Imagine, if you will, a cosmic dance between the sun's magnetic field and its superheated plasma. It's a dynamic interplay of force and energy that sets the stage for the birth of a solar flare. As the sun's gases churn and swirl, they generate powerful magnetic fields. These fields are like invisible lines of force, twisting and coiling around each other. Over time, they become tangled and twisted, creating knots of magnetic energy in the sun's atmosphere, a region known as the corona. But like a coiled spring with too much tension, these knots of magnetic energy can't stay knotted forever. Eventually they snap, releasing their pent-up energy in a brilliant explosion. This is the moment we've been leading up to, the birth of a solar flare. In the blink of an eye, the sun's corona becomes a cosmic light show. The energy release is equivalent to millions of hydrogen bombs exploding at once. This energy is so powerful that it can accelerate particles to near the speed of light. These particles, along with intense light and heat, form the solar flare. But the story doesn't end here. This burst of energy, this solar flare, doesn't stay confined to the sun. Instead, it races across space, a stream of charged particles hurtling towards the planets. And one of those planets, as we know, is Earth. The journey from the sun to the Earth takes about 8 minutes at the speed of light. But the effects of a solar flare can linger much longer, as we'll explore in our next scene. As this burst of energy races towards Earth, it brings with it potential disruptions. The question isn't just if a solar flare will hit Earth, but when and what happens when it does. Stay tuned as we delve into the impact of solar flares on our planet. When a solar flare hits Earth, it doesn't go unnoticed. Imagine an energy burst from the sun so powerful that it reaches our planet in just 8 minutes, traveling at the speed of light. Yes, that's a solar flare for you. These stellar phenomena can have a profound impact on our modern technology-driven world. But how exactly does this happen? Solar flares are essentially an intense burst of radiation coming from the release of magnetic energy associated with sunspots. When these bursts of solar energy collide with our planet's magnetic field, they can cause disruptions in our technology, particularly affecting radio transmissions, power grids, and satellite communications. Think about it. You're driving along, listening to your favorite radio station, when suddenly the music is replaced by static. That could very well be the result of a solar flare. These flares can cause a sudden radio blackout on the sunlit side of Earth, which can last for the duration of the event, typically from minutes to hours. But it's not just our favorite tunes that can be affected. Power grids, the energy systems that keep our cities running, can also be disrupted. In extreme cases, solar flares can trigger power grid failures, causing widespread blackouts. Moreover, satellites, our eyes and ears in space, are particularly vulnerable. A solar flare's radiation can damage their electronic systems, disrupting everything from weather forecasting and GPS navigation to satellite TV and internet communications. But it's not all doom and gloom. There's a silver lining, quite literally. Solar flares can also enhance the Earth's auroras, commonly known as the northern and southern lights. These flares energize particles in the Earth's atmosphere, causing them to glow and creating spectacular light shows that paint the sky with dazzling colors. The aftermath of a solar flare is a reminder of our vulnerability to the sun's immense power. Our reliance on technology ties us closely to the workings of our nearest star, making us susceptible to its outbursts. But it also highlights the importance of studying and monitoring solar activity to better understand and mitigate the impact of solar flares on our world. So, we've journeyed from the sun to Earth, following the path of a solar flare. We've witnessed the birth of these fiery giants, their explosive emergence from the sun's roiling surface. We've observed their voyage across the vastness of space, a journey of millions of miles that they complete in mere hours. Upon reaching Earth, we've seen how these solar flares can disrupt our modern way of life, interfering with radio transmissions and impacting our technological infrastructure. We've also understood the importance of monitoring these space weather events to predict and mitigate their potential disruptions. But perhaps most importantly, we've learned that our sun, the very source of our existence, is not just a silent, distant observer. It's an active, dynamic entity, constantly interacting with us in ways we're only beginning to understand. As we continue to explore and understand these celestial phenomena, we realize that our relationship with the sun is much more dynamic than it appears.